Imagine a giant invisible bubble surrounding our entire solar system, one that shields us from deadly radiation and the unknowns of interstellar space. This structure exists. It's called the heliosphere, and it may be one of the most important and least understood features in our cosmic neighborhood. The heliosphere is formed by the solar wind, a continuous stream of charged particles emitted by the sun. This wind travels outward in all directions at supersonic speeds, carrying the sun's magnetic field across the solar system. As it expands, it creates a vast protective bubble that separates us from the harsh conditions of interstellar space. Inside this bubble, the solar wind dominates. Outside it, the space between stars is filled with cosmic rays, magnetic fields, and matter expelled by distant supernovae. The boundary where the solar wind slows down and begins to interact with this interstellar medium is called the termination shock. Beyond that lies the Helios sheath, a turbulent region where solar wind and interstellar material mix. The very edge of the heliosphere, where the solar wind's strength can no longer push back against the interstellar medium, is known as the heliopause. This is the true outer boundary of our solar system's influence. Beyond it lies interstellar space. Two spacecraft have crossed this boundary, Voyager 1 and Voyager 2. Launched in 1977, these pioneering probes have traveled farther than any human-made objects. In 2012 and 2018, respectively, they passed through the heliopause and entered interstellar space, sending back priceless data about the environment beyond. What they've found is astonishing. Outside the heliosphere, the density of particles increases. The temperature shifts. Magnetic fields behave differently. It's like crossing from a warm ocean current into icy open waters. The rules change. Yet, the heliosphere isn't a perfect sphere. It's shaped by the sun's motion through the galaxy, forming a comet-like tail behind it. Some scientists believe it may be more of a croissant shape, pinched at the sides by magnetic pressure. The true shape remains a subject of research and debate. Why does the heliosphere matter? Because it's our first line of defense. Cosmic rays, high-energy particles from supernovae, and other violent galactic events constantly bombard the galaxy. Without the heliosphere, Earth would be exposed to far more of this dangerous radiation. It could damage satellites, harm astronauts, and potentially affect climate and biological evolution. In fact, some researchers believe variations in the heliosphere's strength over time may correlate with past mass extinctions or climate shifts. As the sun moves through different regions of the galaxy, encountering interstellar clouds or denser particle fields, the heliosphere may compress or expand, altering how much cosmic radiation reaches Earth. Studying the heliosphere also helps us understand other stars. If our sun has such a structure, what about other stars with strong solar winds? Might they have their own protective bubbles? If so, these stellar astrospheres could be essential for shielding exoplanets from radiation, a key factor in the search for habitable worlds. And here's where it gets even more exciting. NASA's Interstellar Mapping and Acceleration Probe, IMAP, set to launch soon, will provide a global view of the heliosphere and its boundaries. It will study how solar wind particles are accelerated and how the heliosphere interacts with the galaxy beyond. Other missions, like the Voyager probes, continue to push the frontier, sending back faint whispers from the edge of space. These signals, often no stronger than a cell phone tower's ping, contain clues about our place in the galaxy. On Earth, we're building better models to simulate the heliosphere in 3D. These simulations help us prepare for changes in space weather and understand how the sun's influence extends far beyond the planets. But there's still so much we don't know. How thick is the Helios sheath? Does the heliosphere fluctuate in shape or strength with the solar cycle? Could it collapse entirely under certain cosmic conditions? These questions are more than academic. They affect spacecraft design, human exploration, and even the future of interstellar travel. Any probe leaving the solar system must pass through the heliosphere, and understanding that journey is critical. For now, we live comfortably within the heliosphere's shelter. But someday, humanity may venture beyond it. And when we do, we'll be stepping into a realm shaped not by the sun, but by the collective forces of the galaxy. Here at Infinity Beyond, we explore these boundaries not just to inform, but to inspire. Because the edge of the solar system isn't an end, it's a beginning, a gateway to deeper questions, to new discoveries, to the infinite. So next time you look up at the sun, remember, it's not just warming your skin. It's building a cosmic shield, shaping a bubble of safety that stretches billions of kilometers across space. And that shield is our silent guardian, keeping the stars at bay while we gaze toward them with wonder.